This next unit is about solutions. When we talk about solutions, they're homogeneous mixtures, meaning they look all the same, they look even. Solutions have a solute and a solvent. The solute is dissolved in the solvent. In other words, the solute is the substance that's being dissolved, and the solvent is the liquid in which the solute is dissolved. An aqueous solution is one that has water as its solvent. The process of forming a solution is called solvation, and that's when solvent particles surround the solute. And you can see that in the picture below. The solute is the green and blue molecule here, and the solvent is all that other stuff around it that's surrounding it and breaking it into little pieces. The general rule we use to determine whether something gets dissolved is called like dissolves like. Like refers to the solvent and the solute being either polar or nonpolar. And generally, polar solvents are going to dissolve polar solutes. Nonpolar solvents dissolve nonpolar solutes. Like dissolves like. Water is a polar molecule, and it's also called the universal solvent. These words should look pretty familiar to you, soluble and insoluble. We talked about these when we used the solubility rules on your star chart, but just to remind you, soluble is when a substance dissolves, and insoluble is when the substance does not dissolve. There's a few factors that affect the rate of solvation or dissolving, and those are agitation, which is stirring, shaking, and that allows the particles to dissolve faster. The second one is increasing the temperature, so if you add heat, that allows the particles to move faster and dissociate from each other faster. And the third one is particle size. Smaller particles increase the surface area for the solvent to act on and to dissolve that solute. Usually, when you look at the effect of temperature on solubility, the more temperature, the more soluble something is going to be. You can see, as with the sodium chloride down here, that that's not necessarily true for everything. Solubility is defined as the maximum amount of solute that will dissolve in a given amount of solvent. And usually when we see this in a chart or graph like the one you see here, you're going to be using about 100 grams of the solvent, just so you're using the same amount for each thing. Then, plotting the solubility against the temperature, you can make graphs like the one here that show different compounds and their solubilities and how those solubilities change as you add heat to them. Some solubility terminology that you need to know is saturated, unsaturated, and supersaturated. A saturated solution is one that contains the maximum amount of the dissolved solute. An unsaturated solution contains less than the maximum amount of the dissolved solute. And this one's a little tricky, but the supersaturated solution contains more than the maximum amount of the dissolved solute. You may be saying, more than the maximum amount? That doesn't make any sense. But we can make supersaturated solutions by doing some of those things we talked about on the previous slide. We could make them by superheating the solvent so that more solute will dissolve than usual, or by increasing the agitation. Things like that can allow you to make a supersaturated solution. Alright, looking at the solubility curve graph, we're going to try to interpret it and see what this means. So it's looking for a type of solution that contains 70 grams of PbNO3, so that's our lead nitrate, this green line here, at 40 degrees Celsius in 100 grams of H2O. We got our 100 grams of H2O, so don't care about that. That's already in our graph. So now we want to say, okay, we've got 70 grams, that's going to be here-ish, at 40 degrees Celsius, which is here. So if I were to plot that point, it'd be right about here. And then we need to look at, okay, is it unsaturated, which would be below the line, supersaturated, which would be above the line, or saturated, which would be right on the line. and our point is pretty much right on the line. So we're going to call that a saturated solution. Looking at another graph here, now we have a solution that has 20 grams of sodium chlorine, so that's going to be NaCl, this blue line, at 80 degrees Celsius in 100 grams of H2O. And we have that over here, so don't care about that number so much. Okay, so at 20 grams, here's 20 grams, and it's at 80 degrees. So if we were to plot that point, it would be about here. So is that below, above, or right on the line? It is below the line, so if it's below, we call that unsaturated. It hasn't yet gotten to that max solubility point on the line. Okay, looking at another one. This one is asking about what type of solution is it that contains 120 grams of K2NO3, so that's our potassium nitrate up here, the red line, at 60 degrees Celsius in 100 grams of H2O. And it tells us this is in 100 grams of H2O, so that we don't really have to worry about. So we're looking at 120 grams, just here, and 60 degrees. So if we were to plot that point, it would probably be about here. So if we look at that and try to say, okay, is it above, below, or right on the line? And this one actually is a little bit above. I didn't really plot the point very well, but it'd be a little bit above that red line. So since it's above that red line on the solubility curve, we're going to call that a supersaturated solution, above the maximum.